All right, so today is a day one lesson, and our essential question is, how do I graph? Oh boy, how do I move? Oh boy, what happened? Let's see if I can
Miss
move it back.
Boyd,
Look at that.
what are you
All right,
doing?
just playing with some stuff. How do I graph and transform rational functions?
Why do you
Great
learn
question.
this? Great question. Rational functions can be used to model the cost per person for group events, such as a band trip to a bowl game.
Fun.
A rational function is a function whose rule can be written as a ratio or fraction of two polynomials. The parent rational function is very important. It is f of x is equal to 1 over x. Its graph is a hyperbola, which we kind of talked about it, which has two separate branches. It says you will learn more about hyperbolas in chapter 10, but we won't because you will be on summer vacation at that point. So like log and exponential functions, rational functions may have asymptotes. Remember everyone, an asymptote is a line that is approached but
close
never reached
to the axis.
Right, so as x gets really, really large, or as x gets really, really small.
Close to it, but never touch it.
So asymptotes are always dashed lines. They're never solid lines because the values on that line are undefined.
Okay.
So you have vertical asymptotes and horizontal. A vertical asymptote always is in the form x equals because it's a vertical line.
Yep.
Horizontal asymptotes is always in the form y equals because it's a horizontal line.
Got it.
And there's our example of our hyperbola, the two separate branches.
Okay.
The rational function, f of x equals 1 over x, can be transformed by using methods similar to those used to transform other functions. You know this formula. We have used it.
Yes.
A, remember A represents, well, the absolute value of A, I should say, represents if a function is stretched or compressed.
So before you had it in front of your parentheses, the number was A. Okay, so now it's on top of the fraction.
And remember, right, exactly. And remember, when A is negative and there's a negative, all that means is the graph is reflected across the x-axis. Correct. The H represents our movement horizontally, left or right. And our K is our movement up or down. So if
is H the opposite of what we think?
Yes.
Okay.
Yes. So if it is in this form, our function, it's really easy.
Yeah.
So let's do an example.
All right.
So using the graph of f of x equals 1 over x as a guide, describe the transformation and graph each function.
Okay.
So number one, before we start describing it in words, let's maybe because we can't see it, let's write out that form that we had up top.
A equals x
minus h plus k. Yep. And so f of x equals, maybe just
okay.
Or g of x.
Equals.
Okay. So if you look, there is no a because look at the parent function. It's 1 over x. It's still 1. There is no a.
So no stretch or compress.
But what is h? Let's write h equals.
H equals -2.
Opposite, right? And there's nothing added
and no k
behind the fraction or subtracted behind the fraction. So there is no k. K is 0.
Right.
So in words,
yes,
all we write is left 2. That's it.
Great.
And to save us on time, and we're going to show you in class how to use a calculator, but right here, if you look, the blue graph is our original. The red graph is our transform function.
Great.
And it's moving 2 to the left. Oh, and guess what was there something else we were supposed to find? Here? We were supposed to find asymptotes on this one? No, I don't think so. It didn't ask for it, right? No. But as you can see, they're showing an asymptote there, and we're going to talk more about it. Notice where it's at.
It's at -2.
Right.
So it's our h, really. Got it.
Exactly. That's what's going to happen.
Okay.
Let's do, you know what? Let's do this one because it's a little different.
I'll write the original.
Yep.
So f of x equals a over x minus h, right?
Mhm.
Minus plus
Mhm.
k.
Right.
All right.
A.
So a is the same, nothing happened.
Right.
X, we're not adding or subtracting anything.
So H
But-
is 0.
Yeah, h is 0.
Mhm.
K is negative 3.
3.
So we're going down,
Down 3. Correct. So now if we look at the graph, notice the original is in blue and the red is our transformation.
Down
It's
3.
going down 3.
Down 3.
And notice it has a horizontal asymptote
At negative 3.
at -3.
Which makes sense.
And the horizontal asymptote then would be y equals -3. Because if you recall, Miss Boyd, way back when,
Mhm.
the asymptotes were always at x equals h and y equals
Oh,
k.
yep.
It's not asking for that here, but I thought we would talk about it.
All right.
That's it. We should probably save
Save it
this
for
one,
class, yep.
example 3, and example 4. Do you want to save both
Sure,
of
we'll
those?
save both of them.
Okay. Let's go here now.
Oh,
The-
this is what you just talked about.
Oh,
asymptote,
I'm
x equals
jumping
h,
ahead of myself.
Horizontal, y
Right.
equals k.
That's exactly right. So the values of h and k affect the locations of
asymptotes.
the asymptotes, the domain, and the range.
Got it.
Exactly. And so therefore, exactly what I said in the
Nice.
last screen. Okay.
It's like she's done this before.
I guess so. I don't know. Aha.
Here we are.
Here we are.
All right.
So let's start with this one. So let's, yep, I like this. Because you always want to start with what's h, what's k. What's h and what is k.
Great.
So let's write that maybe to the side over
So, yeah.
here.
Well,
Or there.
just
I
put
don't
it
care
in
where you
there.
write
So
it.
h is going to be -3.
And k is going to
K
be,
is going to be -2.
right.
Okay.
So what's the vertical asymptote then? Remember?
Vertical is our horizontal. Oh, I know, but that I go opposite. So is that our h then? Because they're opposite. So I think, yep, I think horizontal doesn't go with h. Vertical goes with h.
Yeah,
It's opposite.
yeah,
so that's
yeah.
how I
Oh,
think
I
of
see.
it.
Okay, okay.
Okay, so it's
So-
going to be
X.
x equals -3. Yes.
Oh, I'm on you're perfect.
Okay, good.
Yep, you are. I'm like, what?
Mhm.
Yes, you're great.
Great.
Let's skip the domain for
Yeah.
a minute and let's
So then
jump down to the
horizontal
horizontal. Y
y
equals
equals
-2. So
-2.
notice,
There we go.
on the side, will you write something for
Yes.
me? X is equal to h, y is equal to k.
Got it.
That's it. So guess how easy this is. And we're going to use, I want them to get in the habit of using this notation.
All right.
So the domain is going to be all x, such that x cannot equal -3.
Great.
So once you have your asymptote, your domain is really easy. And if you don't like the squiggly lines that Miss Boyd did, you struggle with that, just use parentheses too. Either
Okay.
one.
Okay.
So the range then would be all y such that y cannot equal -2. This isn't hard.
No, you just take your asymptotes.
Yeah.
Throw them in.
So the only domain, it's saying every x is going to work except x is -3, and that's because that's the vertical asymptote.
Right.
That's where values are not defined.
Right.
Same with the horizontal.
All right.
We're going to save
Yes.
6 for class.
Great.
Oh, well, let's
Right.
move on. So now we're talking about a discontinuous function and a continuous function.
Okay. So discontinuous would be like,
Yep, there's gaps.
and continuous, bam.
Yep,
All right.
exactly.
Good.
So an example of continuous is linear, quadratic, polynomial, exponential, log. Those
Goes
are all
on.
continuous.
Yeah.
The graphs of some rational functions are not hyperbolas, meaning, remember, hyperbola are the two separate branches?
Yep.
Consider the rational function right there in front of you and its graph.
Mhm.
What we're going to do right now, this is kind of an example leading into an example.
Okay.
So it's going to ask us now to find x-intercepts. And remember, an x-intercept
That's
is
when you
where,
say y equals to 0.
and it's where the graph crosses the
Oh, yeah.
x-axis.
Mhm.
How would
Oh,
you find?
So we can just use our graph?
No?
All
We're
right.
not, well, you can, but we're not going to.
Okay.
Because it's really not hard.
Okay.
Because what an x-intercept is, when you have a function like that,
Mhm.
it is the x values that makes the numerator
Oh.
0, the top.
Gotcha.
Right. So we're going to set that equal to 0.
So x minus 3 equals 0,
Yes.
and x plus 2 equals 0.
Yes.
I'm going to change
Yeah,
that.
yeah, because that looks like not equals.
I know.
Come on.
So x equals 3
Yes.
and x equals -2.
Those are the x-intercepts.
Oh,
See how
that's the
easy
answer.
that
That's
is?
easy.
The numerator is 0. What x values make it 0? So now the asymptotes. Let's go look at that. Now the asymptote is, remember, can you write a word for me? Oh
Sure.
man, I spelled
It's
it
all
wrong.
right. It's all right.
Can you write not defined? Because that's where, so what do you think we're going to do, Miss Boyd? It's the x values
The
that make it
bottom?
not defined. Yes.
The denominator?
Yes.
Where it's 0. So
Yes.
x plus 1 equals 0.
Mm-hmm.
So x cannot equal.
Well, no.
Or it does this time because.
Yeah, remember, when you're
because
finding the
got it.
asymptotes, it's always x equals. It was
Gotcha.
when the
So
domain
x
and
equals-
range.
Gotcha. So x equals -1.
Right. That
Right.
is a, can you write, that is a
Mhm.
vertical, because it's x equals
Right.
a vertical asymptote. And the graph is displayed to the right.
Great.
So that's really makes sense. If the asymptote, it's where it's not defined,
Mhm.
you're going to look at the denominator.
Yeah.
And
makes sense.
x-intercept is where it is defined.
Right.
It's where the graph crosses the x-axis.
Makes sense.
Look at the numerator.
That's easy.
Yeah, there's the graph.
Great.
So, oh, this is different.
Mhm.
Okay. It's kind of a long video, but we're gonna,
Yeah.
let's see.
Hold on one
Oh,
second.
oh.
I just have to. Oh boy.
Oh,
Don't
Miss-
mind me. I'm hitting. Oh boy. Now what
Okay,
did I do?
we're gonna get Miss Boyd out of
Oh,
here.
this
She's,
guy? Oh, you got
cancel.
it.
What
Thanks.
do you want me to do? Hit stop?
Pause it for a
Okay.
second. Thanks.
Sure, we'll be right back. Well, we are not back, but I'm back. Miss Boyd had to go to a meeting. So I'm going to do my best. She is a way better writer than I am, but I'm going to really try to finish this video. There's not much left. So we're, again, going to talk about zeros and vertical asymptotes. On the prior example, it was already factored for us. And we found the 0 by looking at the numerator, or the top of the fraction, and said what x values make that equal to 0. And the asymptote, or in this case the vertical asymptote, is found by looking at the denominator. So when I look at this function in example 7, number 1, I have to factor. So notice we're factoring again. So what I'm going to do is I'm going to write, well, okay, I'm going to try to write, here we go, a parenthesis and a parenthesis, and just like factoring. Now I'm a little slower than Miss Boyd at this. I'm trying. So remember, we need an x and an x, because x times x is x squared. And now we need two numbers that are going to multiply to -4 and add to 3. Okay, well, first of all, what I like to do is I'm just going to put in a 4, because I know 4 times 1 is 4. Now I got to decide which one gets the negative, which one gets the positive. Well, I know the 1 is going to have the negative, and the 4 is going to have the positive, because 4 plus a -1 is 3, and that's what we want. All over, oh boy, there we go, x plus 3. I did it. Oh my. Okay, Miss Boyd's going to be so proud of me. We did it. Now it's just like the example we just did on the last page. The zeros are where we look at the numerator and set each of those factors equal to 0. X plus 4 equals 0, and x minus 1 equals 0. Well, we can do that. It's quite easy. Subtract 4 on both sides, right? So if we subtract 4 and we subtract 4, we get x is equal to -4. There's a 0. And over here, we're just going to add 1 and add 1 and cross those off. When they cancel, I'm going to cross those off. X is equal to 1. So our two zeros are x is equal to -4 and x is equal to 1. The vertical asymptote, we look at the denominator. The denominator is x plus 3. So I'm going to set x plus 3 equal to 0. Well, we know we subtract 3 on both sides, so you know x is going to equal -3. That is the vertical asymptote. And if we look at our picture here, there's the graph. The vertical asymptote is the dashed blue line. Remember, that is where the function is undefined, and that's why we look at the denominator. So now I'm going to go to the next page and try to go to the next page here. And we're not doing that, we're skipping. Video questions. So identify the zeros of the function. The zeros, you have to factor the numerator. The zeros, you look in the top. And then identify the vertical asymptote of the function. So you're looking at the denominator. That is it. Sorry, this is a longer video. We will see you tomorrow.